Hello and welcome to Empowered Learning. This is the third example of graphing rational functions. The function that we have now is g of x equals x squared divided by x squared minus x minus 2. So to start this one off, of course, we see that our denominator isn't factored out, so we're going to try to factor it out if we can. And so in factoring it out, we see that we should have what is this? X minus 2 times x plus 1. And so that's what that would factor out to be. Of course, our numerator would stay the same. And so now when we compare numerator with denominator, we see that we do not have any common factors. So this tells us that we have no wholes, or put it a more fancy way, no removable discontinuities in our graph. So the next thing that we need to do is we need to find out what our x-intercepts are, if any, y-intercepts, if any, as well as what our vertical asymptote or vertical asymptotes may be, and whether we have a horizontal asymptote or oblique asymptote, and what that might be. So let me clean this up right quick. All right, so the x-intercept is found by looking at the zeros of the numerator. And so if we look here at the numerator, if we plug in 0 for x, 0 squared would be 0. So that means the point for our x-intercept would be the origin, the point 0, 0. Well, by definition, if your x-intercept is the origin, the point 0, 0, then your y-intercept must be the same thing. And so now if we look at the vertical asymptotes, we notice here that they are the zeros of the denominator. So the value of x that makes the first factor 0 in the denominator, x minus 2, that would be 2. So here we know that x equals 2 is a vertical asymptote. Also, we see for the next factor, if we plug in a -1, that makes the denominator 0. So that means x equals -1 is the other vertical asymptote. So next we need to figure out whether we have a horizontal asymptote or oblique asymptote. As you can see, the degree of the numerator and the denominator are both 2. So because of that, do you notice here that we are going to use the rule that says divide the leading coefficients in order to find out what the horizontal asymptote is. So we know from here we have a horizontal asymptote, and that asymptote is at y equals 1 divided by 1, which is just 1. So we know we have horizontal asymptote at y equals 1. All right, so now that we've figured all that out, the next two things that we need to do is we need to figure out where our function crosses the horizontal asymptote, if it does, as well as the behavior around the vertical asymptotes. So let's look at how to figure out if our function is actually going to cross the horizontal asymptote or not. So here we just say let f of x equal to the horizontal asymptote. And so to do that, we just set our function, which is x squared. Oops, that didn't turn out so hot. Let's just start over. So we have x squared, all that divided by x squared minus x minus 2, and we have that equal to 1 in this case. And so similar to how we did in example 2 in the previous video, you'll see that if I just take this and divide it by 1 and I cross multiply, I end up getting x squared is equal to x squared minus x minus 2. And so from there, if I were to solve for x, I can subtract both sides by x squared. which will cancel those to 0, and you just have 0 is equal to negative x minus 2. And so from there, we know if we add x to both sides, we end up getting x is equal to negative 2 here. So we see that we do have a place where the function crosses the horizontal asymptote, and that will be at the point negative 2, 1. So we're going to note here that g of x crosses HA at negative 2, 1. Okay, and I know I named that f of x and it should have been g of x, so I apologize about that. All right, so now that we have that, the last thing that we want to do is we want to look at the behavior of the vertical asymptotes, the behavior around the vertical asymptotes for both of our vertical asymptotes, x equals 2 and x equals negative 1. All right, so let's make some room here and we'll go ahead and look at the behavior around both vertical asymptotes. So for this first one here, we're going to say near x equals 2. We know that g of 2 is going to be approximately equal to, and so now what we're going to do is just plug in 2 everywhere except for the factor that makes the denominator 0. And so in this sense here, let's go back up just to make sure that we have the right function here. Okay, so we got x minus 2 and x plus 1 in the denominator. So we'll make sure that we have that. Okay, so here we're going to plug in a 2 in the numerator, and we will not plug in a 2 into the x minus 2 factor there, but we will plug in a 2 into the x minus 1 factor in the denominator. So that gives us 4 divided by 2 times x minus 2, which gives us 2 times 1 over x minus 2. So the main thing that we want to remember here is that we know that 2 times 1 over x minus 2 looks a lot like 1 over x. It's just moved over 2 units to the right. So the basic profile of, or the basic behavior around the vertical asymptote x equals 2 is going to look like this. Okay. So now we'll do the same thing near x equals negative, near x equals negative 1. So we'll get near there. So now we will plug in negative 1 everywhere except for the factor that has x plus 1 in it. So we got negative 1 squared, and we'll have negative 1 minus 2, and then we'll have x plus 1. And so, of course, negative 1 squared is just a positive 1, and negative 1 minus 2 is a negative 3. And we have all that over 1 over x plus 1. And in this case, this is going to look like a lot like negative 1 over x instead of positive 1 over x. So here, general shape will look like this. So now that we have all that information, we know how the basic graph's going to look. We know what its x and y intercepts are. We know vertical asymptotes. We know horizontal asymptotes. And we know where the function actually crosses the horizontal asymptote. So let's go ahead and move on to the graph and show everything at once to show how the graph turns out. Okay, so now that we have our graph ready here, we'll go ahead and do the same thing we did last time. I'll go ahead and label these in half units so that we can see everything real well. And we know that we have x and y intercept at the origin. We also know that we have vertical asymptotes at 2 and at -1. So of course I'll draw the one at -1 first. And we'll draw the one at 2. So that would be right there. Remember, I'm doing everything in half units, so that's why it looks twice as far as it normally would be. Okay. And so the other thing that we know is that we have a horizontal asymptote at y equals 1. So we'll go ahead and draw that now. So this is y equals 1. And this will be x equals 2. And this is x equals -1. And the last two things that we need to note is we know that at the point -2, 1, our function actually crosses the horizontal asymptote. So that would be about right here, crosses. And the last thing is the behavior around the vertical asymptotes. So we know that when x is equal to 2, that vertical asymptote, we know that it looks like 1 over x. So we start here, kind of swoop down like this. And on this side, we start down and kind of swoop to the left like that. When x is equal to -1, that vertical asymptote, this is going to look like -1 over x. So it starts up here, has to swoop down kind of like that. And on the right side starts down and has to swoop like this. And so now that we have all this drawn here, we can now prepare the graph for the final drawing. And so on the left side, notice that we have to come up here and then go through the point on the graph where crosses the horizontal asymptote, and then after that come back and ride along the function this way. Coming from the other side, we know we start down, we come up, and we're going to have to touch where we have the x and y intercept and then come back down like this. And of course that makes sense to us because the degree of the numerator here is 2, which has even multiplicity. And so from that, we know that it should bounce off of the x-axis right there. And then lastly, we come here, draw, and then just swoop down and ride along the line y equals 1. And so this is what g of x equals x squared divided by x squared minus x minus 2 looks like. Please check out the next example, example 4.